Everyone. Hello, everyone.
Hello.
Hello, everyone.
So it's
Last
cold.
day.
Oh, it's a long road. But we made it.
We can sleep now.
Let's
We can sleep at night.
get through this. So today we're covering 24 and 25. Ooh, the end of it.
Last 2 days.
Yeah. And so let's start with 24.
All right.
Scott, you did yours on Excel.
Yep. Well, I tried coding at first.
Okay, you tried coding.
So I do have a tiny bit of code that I could show, but there's a giant disclaimer at the top that says, do not try to run this code because it'll take months.
Yeah, certainly.
And then I went to Excel to finish up.
Yeah. Well, that's perfectly valid. They only want answers, right? They don't want your code, so
Yeah.
answer's valid. Anybody else give it a go, or?
Yeah,
not yet.
I gave it a go
Okay,
since yesterday, and so I have answers for part 1 and 2.
sweet,
Oh, nice.
Yep.
sweet. Well,
Took
let's
some
start with-
help.
Do we review the question first?
Oh yeah, let's review the question. Let's see.
I took some help, but I got it working.
Yeah, whatever.
Cool.
All right, so this is the ALU. There's a whole bunch of instructions that come in, and you have to basically follow the instructions on the way that it goes from register to register. You have two memory registers, A and a B. Depending on the instructions, you have to do something, right? And typically, the first register is a register you write to, and the second register is, the modifier or the other operand for the operation. So an add, you have add A and B, but you store it in A. Multiply, you have A and B, but you store it in A. Divide A and B, but you store it in A, and so on and so forth. The only different ones are the equal returns a 1 or a 0, depending on whether it's true or false. I think that was it for the first one.
What's it? The division one was important because it rounds down, I believe.
Yeah, it truncates.
Yeah. So that's a key for later.
Yeah. And there was another one, I forget. They're always positive. Well, I don't know, maybe I'll figure it out once we get into it. It's been a while since I looked at this one.
We have 4 values that we're going to track: W, X, Y, and Z.
Yeah. And so as this stuff comes in, essentially what we're trying to do is trying to get the largest model number that's acceptable by the algorithm that you have been given. And so we know that it's acceptable because at the end of it, the last register, the X register, or is it the X? No, the Z?
The Z.
The Z register
has to get to 0.
has to be 0. It starts at 0 and ends at 0. And that's a big clue as well. But anyhow, that was that. And I think looking at some of our inputs, like let's see if I can look at my input really quick. You see, there's quite a bit going on.
Yeah. I think this one, everybody's input is the same length.
Most likely.
But the only thing different is some of the values and some of the division steps will be a little bit different. But there's definitely a pattern that you can notice.
Yeah.
If you start looking at your input carefully. And that ended up, for me, being the key to actually getting an answer.
Well, show us how you did it, man.
All right, well, I'll show you my code first, if you're interested. So I put a giant warning at the top to remind myself not to even bother running this code because it's terrible. And
I like it. It's like an ocean.
it does run, but it doesn't stop. It just keeps running, and it will probably run for months, I think, before it would actually find an answer. And the reason for that is because I'm checking pretty much every possible number between whatever this is. I can't even.
Scott's 9.
Let me add in some comments just so I can even read this. Yeah.
99 quadrillion.
99 quadrillion. So pretty much 100 quadrillion.
Oh no, it's trillion. 99 trillion.
Million, billion. Yeah, pretty much 100 trillion. Down to only 11.1 trillion. But I'm checking every number in that range.
Without zeros.
Yes, that's why, yeah, any number that doesn't have zeros. So one of my first conditions here is I'm checking if it has a 0, I'm just going to continue. But anyways, I have code to pretty much just loop through and run all the lines of the input. Run all of these lines, all these 252 lines of input for every possible number. And that doesn't work. Like, I didn't.
It will if you have enough time.
Yeah,
Surprisingly,
if you
surprisingly.
don't need your answer until 2023.
Yeah. Until the next advent of code.
So yeah, I think that my answer probably would work actually, but it would take way too long to even be worth running.
Cool.
So that's that. And my second step then was to ignore that and go on to Excel.
Of course, it's what everybody does. Can't program it, we'll do it in Excel.
Well, actually, instead of Excel, I believe I use Google Sheets because I don't have Excel on this computer.
Just as good.
Essentially the same. Can you see my Google Sheets here?
Yep.
Yeah.
So I went through my Google Sheets. I copied and pasted all of my instructions. And then I went through and tracked every single variable at that step. So in order to do this, I decided that I needed to create variables for the different digits in my 14-digit number.
Okay.
Because I didn't want to just have 0, 1, 2, 3, no. So I started with, I think I have A, B, C, D, E, F, G, H, I, J, K. I don't like lowercase l, so I went with a capital L. And I think N might be the last one. Is that 14? I think so.
Okay.
So yeah, so I'm going to use these variables for the different digits. So at the beginning, when we import W, or what is the INP? Import, I guess.
Input.
Input W. So my W now is going to be equal to A. So that's going to be the first digit here. Which side are we starting on? We're starting on the left, right? I believe.
It's your code. I don't know which one you want to
Well,
start.
for the actual, for the problem, I think we have to start on the left. I'm not sure. Of the 14-digit number.
Oh, yes.
We started on the
Ah,
left, right?
Okay, gotcha. Yeah.
So yeah, so then A would be on the left here. So then, yeah, I went through and I found every single value at that point in time. And after a while, I start to realize a pattern. Actually, this is not the first time that I went through this Excel sheet. I had to go through, things didn't look good, so I had to realize more patterns and then change some things. So eventually what you can realize is when we have multiply Z and Y and add Z and Y, things just keep getting bigger. So Z just keeps growing. And there's a lot of multiplied by 26 steps in here. A multiplied by 26, B plus 6, and then you multiply that by 26. So there's a lot of multiply by 26 steps. And eventually you get to a point where, I guess this is probably different in everybody's input, where you actually
I cannot hear you.
now you're popping off
Yeah.
the last
I
element
can.
that you added. So here you can see the last element that I added was going to be E plus 9. And so now my X is E plus 9 because I did the modulo of that. And when I divide by 26, now I'm pretty much just getting rid of that E plus 9. So it essentially becomes like a stack where you're just adding things on and then popping them off. And every time you pop something off, you can end up with an equation that will tell you 2 of your digits in your number. Well, it'll give you the relationship between 2 of the digits in your number. So here I have one of my equations here is F is going to equal E plus 7. So at the top here, I know that the F digit is going to be E plus 7. And if I keep going, I marked all of these, I believe, with a bunch of exclamation marks so I can find them easily. So here I have another one. H is going to be G minus 5. I is D minus 8, and so on and so on. So at the end, what I had to do to get my maximum numbers was to solve all of these equations, setting the larger of the 2 values as 9, and then calculating the smaller value. So here, for example, F is going to be E plus 7. So I'm going to set f as 9 because that's the largest possible value. That means e must be 2. So I'm going to do this for all of the different numbers and then put them into my 14-digit number in the correct order. And I'll end up with my answer. And likewise, I can do the exact, should I go with part 2 or later?
Let's just do them now.
Yeah, part 2.
It's just the same, but
Part 2 for
lowest.
this one was the exact same question, except instead of finding the maximum number, you have to find the minimum number. So since now I need to find the minimum number, instead of setting the larger value to 9, I'm going to set the smaller value to 1 because that's the smallest possible number. So again, for my f equals e plus 7 example, now I'm going to set e, the smaller number, to 1. That means f is going to be 8. And I do that for all of the equations that I got, and I get my final minimum number. So I think that after knowing all of this information that I know now, coding this would not be too hard. I think it would be simple enough to just create a stack. There's a lot of lines that I think you can safely ignore. You pretty much only need to get the plus, the digits that you're adding, and figure out when you divide by 26, and it's not going to be that hard. But without knowing that information, coding this was near impossible, I think.
Cool.
We're done.
Makes sense. Makes sense.
Surprisingly, your part 2 answer for Alex was a huge number too, no? Like the first digit was 9 for your part 2 answer, Alex?
Yes. Part 2, my digit was also 9.
Hmm.
So there wasn't much difference between my lowest and my highest.
Oh, okay.
And so when I first generated the answer, I was like, oh man, something broke.
You didn't trust it.
I didn't trust it. I was like,
I thought it should be a
that
1.
can't be the lowest, right? I thought it should be around like 1 or 2 or something like that. I was like, 9 again.
I guess depending on the equation, it could be.
If you started with ones for your part 2, you waited quite a long time, right? To get the answer.
Yeah, no, but I didn't brute force it. It was just not going to happen. There was way too many possibilities. And the way that I did, there's just too many possibilities. So I did it a different way. I actually did it similar to what Scott had just suggested, but through a program.
Okay.
Let's see yours, Farouk.
Wow.
Okay. Here's mine. So first, this is my attempts in code, but this is my logic here. Okay. First, one thing was obvious that a lot of the instructions were similar to each other in every 14 type of digits. The instructions were really similar. So I tried to find the pattern in each of them. And one by one, I tracked every line in every set of instructions, and I found that almost, how many? 1, 2, 3, 11 of them are same. 11 of the 14 instructions are same. So I decided what kind of influence or what kind of effect they're having on those different values we have, like X, Y, W, and Z. So if they are similar, the output we are getting should also be quite similar. So starting from the top, I tracked how they are changing our initial values. So here in every line, every time we are setting X to 0. So no matter what value we start with X, it's always being set to 0 as soon as we start our operation. And then it's adding Z to X, which is effectively setting X to Z. And after that, we are getting modulus of X for 26, and it will set X to Z26, Z modulus of 26. And it will be, so eventually X will be a digit, which is, or integer, which is less than 26. What this is doing is, and after that, we are in some of them, because it's not same for all. In some of them, we are dividing Z by 1, which is not changing it at all. And some of them, we are changing it by, we are dividing it by 26. So, which is type 2. Second type of instruction, because from this point on, their effect on the initial values will be different, because it divides by 0, but some of them are dividing by 26, which is setting Z to Z divided by 26. And after that, we also have another different operation, which is adding a certain digit to x. And some of them, you can effectively see that adding an integer to x, and these integers are higher than 9, which is important to note. And some of them have negative integers here, or 0, but some of them have always digit higher than 9. And it's important because in the next step, we are comparing our x with w. Our w is our input, and we did not change it since the start. And our input is always a digit between 1 and 9. So when we add an integer higher than 9 to our x here, our first type operations will always set x to 1, because they cannot be equal. Like our w is between 0 and 1 and 9, and our x is higher than 9 in some of them. But some of them here, surprisingly, our type 2 again, are decrementing our x here. So there's a possibility that it might be equal to w, it might be equal to our input. So you see, this is for the type 1 operations. For type 2, so it will be lower than, there's a possibility that it will be equal to 9. This is for part 1. And next, we are comparing x with w. So for our type 1 operation, it's always 0 because they are not equal. But for our part 2 type of operations, which have 0 negative integers, there's a possibility that it can be 1, which is they can be equal, or it can be 0. It may not be equal for type 2. And next, we are converting or reversing our binary, basically. Here it was 0 or 1, our x, and here we are converting it to opposite. If it's 0, we convert it to 1. If it's 1, we convert it to 0. So up until here, we work with x, and here we'll set our y to 0. So basically, we worked with our x, and from here on, we are working with y. We set it to 0, add it to 25 in all of them, which will make it 25, and multiply y by x in all of them. So our x was relatively 1, 0, or 1, so it will be 25 or 0 or 25. Adding y to it, it will set our y to 26, multiplying z to y, we'll have 26z, because our y was 26, or z divided 26, because in some of them we are dividing z by 26, or z. One set of operations are done, and after that we are setting our y to 0 again here. So 0, we set it to our input, and we add 12 to it. In here also it's different. So in some of them 10, 12, 10, whatever, different digits. So in the range, we have a certain range of numbers that will increment our increment y, and then we'll multiply y by x, and at the end we'll add y to z. So at the end of all the operations, we have 3 types of output we can end up with. The first one being, we can end up with y equals to 26z. No, it's z equals 26z, which will increment our initial starting z by 26 and add some integers to it. So basically it will increment our z. Or next one is, it can end up with z divided by 26 plus some range of integers. This will decrement our z. Or this is second type of operation which can end up in 2 types of outputs. One of them can decrement our z, or one of them can just increment by marginally small integers. So if I calculate it, I have 7 types of each. So I have 7 types of operations which will end up incrementing z eventually. And I have 7 types of type 2, which will eventually end up decrementing it or incrementing it by small number of integers. but we want z to be equal to 0, right? And to make that happen, it should follow their set of instructions. It has to increment it by 7 of them will increment it by 26, and 7 of them has to increment z. Increment it 26 in order to make it equal to 0. So we cannot have this possibility. We should not have this possibility. We need to try. I need to try to get my z, my type 2 instructions, decrement z by 26. To make that, we have to get our w. So we have our operations here. And to make that happen, we have to follow the lines from 2 until 7 here. So up from here, we have our x set to 0. And at the end, we are ending up comparing our input to x. So to make the decremental possible, we have to make our w equal to x. So here, what we are doing is we are getting modulus of 26 of x and adding a certain number to it. In each operation is different integer. So we can decrement or we can subtract this number from our x and get modulus of it to get our next input digit. So for type 1 operations, we can have any range of digit between 1 and 9. But for type 2, we can calculate our digit based on this calculation here to get our w. Shown here. Can get the modulus of 26 and decrement the given digits in our input from x. That's the logic. Any questions or clear?
Yeah, that was good. That was a lot of things that I did in my Excel sheet too, but did not explain because it's been so long since I touched this question. I forgot some of the details. So thank you for going through those.
Okay, so I think I had my first run of commands similar to yours. I had my custom ALU function, which will make the appropriate operations. And then I had my range, starting range for 7 digits, because the next 7 I was planning to calculate based on the type 1 operations. My type 2 operations needs to be calculated. That's how I am decrementing the number of loop runs. I have 7, but here I couldn't get the logic to decrement my input by 1. So then I found the product in Python that will provide the possible combinations of the given range. So I'm now creating my range of 7 integers, 7-digit integer, and digits ranging from 1 to 9 using this product. And after I get this range, I'm calling my make operation function for each of the digits. In my make operations function, I have my z set to 0, and I have my response, which will be the output integer of 14 digits. And I have my current index. And 14 for the 14 digits, I'm running my loop here, and I'm getting my appropriate values from my input for each of the digits, because one of them is here. Every time I'm incrementing my x by a different value on all 14 of them, but what I need is to calculate type 2 is the ones that are not positive, that do not increment my x. So these are my negative values and 0, because they do not increment x, which will potentially can make my x equal to w. So I get my appropriate integer from my dictionary here and get my next digit which matches here, because it's different in each of them too, and it will update, or it will change the value of y different in all of them. So I need to get that one to calculate my input w. So if my increment is not negative, I will just get random digit from my already existing digits. And if it's type 2 operation, which is in here, I will calculate my next digit with this calculation, which comes from the logic of the previous example. And I will check if it's not smaller than 1 and not higher than 9. That's it.
Well done.
Okay.
All right.
For part 1, it took like 5 seconds. But for part 2, I started with smaller range. So for part 1, I'm generating my tuples with 9, each of them 9, and I'm going downward from 9. And for my part 2, I'm generating ones. So let's see part 1 first. So part 1 answer. And for my part 2, I am populating my tuples with ones. And this is my part 2 answer.
Okay.
So basically same logic. In the part 1 started from the top and part 2 from the downward.
Makes sense.
Right.
Well done.
Alrighty. I'm glad you guys got to go first, because you guys got to kind of explain the patterns that are there. So
There's less for you to explain.
less for me to go over, but I'll try to explain as much as I can. I got different versions here. I put 2 versions in, but anyway, there's also a Python version we'll get to in a second.
Oh my gosh.
Yeah.
I'm looking at the right side there.
Oh,
So this is all the stuff I tried, and in the beginning we have the typical naive. Oh, let's just bang it all out. You can see I just
Loop through 14-digit numbers.
loop through them all and say, all right, let's see what happens. Yeah, I think it'll work. I even have numbers I just tried testing on. The reason I have these tests is because I have other functions that generated numbers, and there's like, does this work? Does this not work? Maybe, maybe not. You can see I tried a couple answers. Some were too high, too low.
I do that sometimes.
Yeah.
Just to get a range.
No, because I thought maybe my algorithm worked, but it didn't. Let's see. There was one section where I tried to do the reverse. So instead of starting from the first and going forward, which is what the validation does in the normal programming, right? You start with the most significant digit to the least significant digit. I created a program to start with the least significant digit and calculated all the possibilities of having 0 at the end. What does the last Z need to be? And then go and generate all the possibilities for the last Z. And then from those possibilities, what are the possibilities for those to have that, and go on like that. And it fans out pretty quickly. So, but interestingly, I was able to get out of the 14, I think I was able to get 11 digits of the answer.
No.
Before it was just like, all right, because to get those 11 digits took less than a minute, but then it started, but every time it goes out, it just blows it, exponentially in terms of possibilities. And, later on, I realized that because my first 3 oops, 24 and as you guys had kind of said that, this is probably some sort of weird queuing mechanism, right? The first three I'm adding to the queue. So, and when I'm trying to blow this out, I think maybe even the first, the first three are adding to the queue. So when I hit those last three, the possibility is just, it was too much. So that was a dead end, but I got a couple out of it. At least I think I did. And I was able to validate later that, yeah, I actually got the first 11 or the last 11, but I couldn't get the first three with this thing. And so I had to go back and figure it all out. But yeah, you can feel free to, there's my reverse gen. This is the function that I use to go backwards and try to reverse the entire process. And like I said, it got up to a certain point and then it didn't give me any more characters, or rather it would just take too long to get the rest of the characters. So I went back to the drawing board. Let's see, what are these other ones? Some of these other ones I just did tests on the reverse to see, does this thing work? But anyways, these are all, I'll show you this one too.
Whoa.
Yeah, a lot of copy paste. I was like, maybe I should just like brute force it with each one of these.
No. Your loops go all the way from A to N. I like it.
Yeah, it's a for loop for every digits.
Yeah. Actually, I think I tried that too.
And it took too long. So that was also a dead end. So, given infinite time and resources, maybe that would have given an answer, but no. So then I went back to the drawing board and I actually started, because it does say in the test itself to kind of, examine the algorithm carefully. And so I think what I did at that point is I went back and I translated it. So I translated it into just math instead of trying to run it through the individual instructions. And so this is how I ended up translating all that stuff. And I was like, oh, okay, now I have a mathematical formula. Can I reverse it? And so I tried to reverse it and no, this is not reversing it. This is me copying, pasting and thinking about reversing it, but not actually doing it. So because, no, actually I did actually try to do some of the reversals, but I couldn't get this one down. And there was just something missing. I just couldn't understand. And so that was a dead end. So the bottom end of the if, I'm pretty sure that would work, but this top end, I don't think it would work. And I don't remember what kind of answers I got, but it didn't look good. And so then I went back and then I spent even more time looking at it. Oh, we gotta get Ferg back in. And so I went back and spent even more time looking at it. And what I ended up with
was a stack.
Nice. So as I was looking at these, I realized there's actually only 3 numbers that are important in every group. And so, in your input, you have, where is it? So, it's not in the top. So before every input, you have 25, 26 lines or whatever of stuff, but there's only about 3 that really matter within. Some say 4, some say 3, but it really kind of depends, because even this line arguably has kind of, I can get rid of this significance just by looking at the plus and minuses here, right? Because I have the 1s when it's positive and I have the 26s when it's negative. And so there are some other like patterns you can pull out. So you could probably, pull it off with only these 2. And so the idea here was, okay, so maybe, and there's, again, the multiplying by 26 and dividing by 26. And that act in and of itself, when you multiply by 20, or you multiply by 26 and you add something to it, and then later on when you divide by 26 and you pull out the remainder, that acts kind of like what we used to do for storing stuff in bits. So I was like, oh, is this possibly just a way to use a number as a stack? And so we looked at it and I was like, oh, yeah, it looks like that's what they're doing. And so then you know that there's 7 1s and 7 26s. And so maybe, and because all the ones are the time, or they have only the times 26 without dividing, those are the ones that add to the stack. The ones that divided by 26 are the ones that are moving to the stack. But of course, it's not that simple, right? Now you also have modifiers as they get put on and pulled out the stack, depending on the value of that number. And then, so looking at these, there is a relationship between these numbers where you have
pairs.
You have pairs.
I like your diagram there from 71 to 75 to show the pairs.
Yeah, so I was like trying to figure out if this was a stack, then it has to be first in, first out. So when you start adding things to it, you have to remove it from the very last one that it was on there. So, you know, for example, the very first time anything gets removed is between these two. And so these two are probably related to each other.
Yeah, the first time you hit the divide by 26.
Right. And so I stared at this for a while and I thought, maybe does the fact that this is 14 and 3 makes 17 have anything to do with that this is 9 and minus 8 is also 17? So then I went to the next one. Oh, okay, so the next pair that I found was this pair, this one and this one, right? And so this has 4 and 9, which is 13. And this one has 4 and 9, which is 13. Or no, sorry. Yeah. And then there's another pair with these two, 8 and 2 and 9 and 11. I was like, oh, that's really interesting. So there's a relationship, a causal relationship between the pairs of these numbers. And so I was like, oh, maybe that's it. And if so, that would make it a lot easier to figure out what the hell's going on. And so there's the code.
That's showing.
Yeah.
Nice.
Well, I mean, there's this code to take in all this stuff and like put it into
just formatting the data.
Yeah, formatted data into vectors, getting the 3 lines that I want, which I just call off lines, which are those 3 lines of numbers. But like I said, you could probably just done it with 2.
Yeah, so you can skip, you didn't even care about a lot of the lines, right? You just skipped through all of the lines except like the 3 that matter, right? Well, the 3 in each chunk that matter.
Yeah, so it's me just pairing up the stack pairs and then determining based on position which one to make 9 and which one to make 1. And so that was, you know, the kind of the tricky thing that I had to go back and forth on. But it looked pretty much like the, you know, whichever one had the least absolute number for the pair was the 9. And so looking at that, and I was like, oh, okay. And so that's what it ended up being coded as. And so we have for each element in the stack, it gets pushed in if, you know, if it's not 26. In other words, if it's not divided by 26, right, it's divided by 1 instead, they get pushed onto the stack. Or otherwise, if it is 26 and then we're popping from the stack, and the popping is where I'm doing my math. And so when I pull out from the stack, I have using those number pair differentials, differences to determine what number to put in. And so that's pretty much how it goes. So it doesn't actually resolve left to right. It goes, adds to the stack, adds to the stack, adds to the stack, pops from the stack, and then now I know these 2 numbers. Yeah. Add to the stack, add to the stack, add to the stack. And pop from this one. Now I know this number. For the next one, I pop from that stack. Now I know these 2 numbers. So it didn't end up incremental. It kind of builds as it goes.
Yeah, you can see it like on your line 67. Every time you have a 26, that one pairs up to the most recent one before it.
Right.
They both get popped off essentially.
For which one?
So like you have on line 67, you have like 1, 1, 1, 26.
Mhm.
And then you can essentially pop off the 26 and the 1 right before it.
Right.
So now you have 1, 1, and then you're going to add another 1, 1, 26. So you can pop off that 26 and
Right.
the
So
1 right
that one
before it.
disappears.
So eventually you get all the way to the end and your last 26 pairs up with your first one.
Right.
So that's why your number, your initial number was a 9 because they're paired up with the very last one.
Yeah, and so my number didn't resolve left to right. It just kind of fell into place as I popped off the stack.
Yeah.
So that was the solution, and to my great surprise, it worked. Great surprise and like elation. I was very happy that this worked.
That's pretty much exactly what I was planning to do if I went back to code it now.
Yeah, looking at yours,
essentially what you
saying.
did.
Yeah.
You really can't do it without knowing the patterns, though. You really have to inspect the input for a long time.
Well, I mean, look at my pain. All my pain.
That's a lot of lines of
It's a
pain.
lot of pain.
Like 800 lines of pain.
Sweat. This is sweat.
Copy and pasted, I assume. So
Some of it was copy
not all
pasted and
hard
just
code.
kind of like, changed a little bit.
yeah.
I think I have, for example, and some of them are just like tests, like the test num2. I'll actually, to see whether or not numbers work, I'll have tests that'll either run through the original version with all the instructions or my second version with the formula. And so let's talk about the formula really quick. So I was thinking like, oh, there's got to be, well, let's back up. Let me do part 2 and then we'll go back, talk about the formula. So part 2 for me was pretty easy. It's just the same thing, but in reverse. Instead of a 9, I assign 1s, right? And so I just comment that out. So it's pretty much the same, except I do it in reverse. And so again, as they're going through the pairs, I just try to figure out now to the least, so you end up with the 1s instead of the 9s. But that little math between those last 2 is what determines these 2 modifiers determine whether it's a what number gets the 1, which of the 2 pairs gets the 1.
Can you re-explain quickly the pair? I don't understand the logic of the pair.
These pairs?
Yeah, like, you draw some line under like to
Okay.
make
Shapes.
a pair.
Yeah, from line, you mean from line 71 to 75?
Yeah, yeah.
Oh,
He's
these are
showing the
just
pairs, like-
showing the pairs, because remember, this is where I'm adding stuff to a queue.
Okay.
And so when the 1s go on, it's added to the queue. So the first thing, the first number, whatever was in the first position, was added to the queue. So so to the stack rather than the queue.
Mhm.
The second number, it was another divided by 1 after I'd done the multiply by 20, 26. So that was another number added to the queue. So that was 2 on top of that.
Okay.
The third one was also 1. So now it's another one added to the stack. The fourth one was a 26. So that dividing it by 26, because these are all dividing numbers on the line 67. Divided by 26 suggests to me, okay, now they're trying to pop something off the stack. Now I have to get the remainder of what was popped off and then do a little bit of math to get back the number, because math was used to assign the number to see whether or not the number was correct in the original algorithm. And so these lines basically visually tell me which numbers were paired up with which, because my algorithm doesn't go left to right and resolve the numbers from left to right. I don't know what number to put in this position, in the first position, actually, until the end of my program.
Okay.
Even the second position, I don't know until I get to this number in my program. Third position, I don't know. Fourth position is when it's interesting for me, because that's my first popping off the stack. And now I can say, because I'm popping off the stack, I have to pop off the last number that I put on the stack. So that's how the stack works.
Mhm.
The last number I put on the stack was whatever was in this place.
Okay. So the 9 and the 3. Okay.
And then looking at the possible combinations of these numbers, I was like, oh, okay, then if this relationship holds, because when we look at the math, we're actually, I believe, we're adding these before we put it to the stack, and then we're subtracting these when we pull them off the stack.
So one of those was like X plus that number and one was Y plus that number, I believe, right?
Yeah.
So essentially it becomes whatever for lines, for that one where you have a 3, you could essentially do 14 plus minus 8. And then you get a difference of 6, right? So then you know,
Oh, yeah.
okay, so
exactly.
then it has to be 9 minus 6.
Yeah, so one of them is
equals the
9.
lower number.
One of them is 9 and one of them is 3, because there's a 6 between them.
Okay.
Oh,
So for later on, for the next time we see, the next time we have a pair, his pair is, the first number is 8 and the next number is 9. And if you look up to the numbers that he's adding and subtracting, you see a 12 and a minus 11. So if you do 12 plus minus 11, you end up with 1. So you know that there's a 1-digit difference between those two numbers in the pair,
Yeah.
right there. It took a lot of looking at the problem.
Right.
You really have to, because you keep adding numbers to your Z value, but when you add a number and then divide by 26, the number that you added is less than 26. So now if you're dividing by 26, it's just, you're pretty much just getting rid of that last number that you added, because it's not going to change the total value when you divide by 26 because you round down. So the key is that you round down every time you divide. If there was no rounding, then this would not work at all. But because you round down and the number that you added is less than 26, you're going to end up with the same value that you had before that last addition.
Yeah. Yeah, it's an interesting way to use very large integers to store information, to store other numbers.
It seems practical after doing this, though. It seems like a system that could be useful.
Yeah.
Not just some random arbitrary problem that this guy created. It seems like a useful thing.
I'm pretty sure it's been used practically. I mean, do you guys understand how those numbers work in terms of how to make a number into a stack?
Not fully for me.
Yeah.
So maybe I can explain it a little bit with different valid numbers. So essentially the validation mechanism for this ALU, it's just comparing pairs of numbers. So the values that we found that Alex has printed on line 71 is the maximum values that you could have. But there's also other pairs, like you could find any other values in there that would still be valid. Although in Alex's example, his first digit and his last digit, that's the only option because he has 8 difference between those. So his first digit has to be a 9 and his last digit has to be a 1 because he can't have 0 and you can't have greater than 9. But if you look at his next pair, so his next pair would be the second digit, it's a 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th digit, the 8 right there. Can you highlight that maybe?
Yeah.
The 8 right to the just to the right of there.
This one?
Oh no, the next 8.
This one.
Yeah, that one. So that one pairs up with the very second digit that he has. If you follow his line on line 73. So you see those ones, there's only one difference between there. So you could change both of those and still have a valid number. You could have the first one there be 8 and the next one 9, and that would still be a valid number. Or 7 and 6, and your number is still a valid model number.
Right.
3 and 2, and it's still valid.
Yeah, but you want the maximum number.
Yeah.
So you know one of these in the pair is going to be a 9.
Be on the front. Yeah.
And so the validation checker is really just checking the different pairs to see if they are the correct, have the correct difference. If they do, then cool, it's valid. But there's a lot of different options for valid numbers, as long as they follow the rules for the pairs.
Storing numbers. Let's see, storing numbers as I mean, you can almost think of it as the decimal system that we have actually stores lots of information. When you take a number, oh, it's too big. Let's reduce it just for the sake of brevity. When you take a number like this, there is information in here. And essentially it's the fact that it's 4 times 10,000, 7 times 1,000, 4 times 100, 3 times 10, 6 times 1. And we take this for granted, but this is how you can encode information into numbers. And so, you know, if we take this and go a little bit beyond, because right now I can only encode with base 10 numbers between 0 and 9. Right? Because that's the only numbers that go in between here. But there are other numbering systems that don't use numbers, like the hexadecimal system.
Yeah, base 16.
Right? And base 16. But let's even stay away from that and go to something like, if I wanted to store the number 625 with this base 26 that they're using. Essentially, you can take depending on whether you want to go left to right or right to left, don't think it really matters. But let's start with the 6. The 6, so you can take 26 as long as you're consistent with everything that you're doing. So you take 26 and basically you say 26 is going to be your first. You can even start with 0, to be quite honest, with the first one. But you have to make sure that the subsequent ones, follow the same base that you have. But let's say you got 26. 26 times 6 is something.
132.
I can do it in my calculator.
56.
156.
156.
Yeah.
156, right? So as long as my next number that I use is greater than 156, I can use that number. So I'll take that 156. Let's see. So 150. Oh, okay. So 156. That's I'm going to store. And I'm going to do a 26 times 2 plus 156, which is what was from the last one. Do I need to push one more out? Do I have enough room without pushing the numbers? Oh, it's been a while since I've done this. Do I have to add? I believe I have to add them in. Oh, this might not work. Here I am trying to show you guys how this works. And I don't even remember exactly how that works. But anyways, let's go with it and see what happens. So 26. So we add 26, we add the last value that we have, 26 times 2 being
52. Sorry. Yeah, 52.
52 plus 156 is
208.
208. Let's go with it and see what happens. The last number, 26 times 5 plus 208.
130 plus 208 is 338.
338. Okay. And so we've somehow encoded the 625 to the 338. So how do we, take this back out? All right. It's a question. So to take this back out, we take the 338 and we divide it by 26. Right? Because we've multiplied everything to 26 to get the number that we want. So now we have to kind of reverse it all. So what is this number?
13.
13. And so we've got so we got a number that we got back at 13. What do we have to? Oh, no, that's too small.
Yeah.
So I missed. There is an exponent value to this that I missed. It's not just 26 because I have to make sure I clear the maximum value of the last one.
I think you need to multiply the total number by 26. So for the second step, for the first step, I think you're good. 26 times 6 is 156.
All right.
But then the next one you'd have to do 156 times 26 plus 2.
Ah, okay, so I got the wrong number.
Yeah.
What's the maximum? What's 26 times 26?
676.
676. So that's the maximum number that I need, at least 676 before I encode the next number. So
I think let's do this. So let's try it. If you just move your times 26. So start with the old number, start with the 156.
Okay.
And multiply that by 26 and then add 2.
Okay. So let's try that. Multiply by 26.
Yeah. And then add 2 to the total.
2 to that. And what does that end up being?
6 times 26 plus 2, 4,058.
4,058. That sounds a bit more promising. Numbers are growing past. I want to make sure at least it gets past 676.
Yeah, you're definitely there.
Yeah.
And now do the same thing. Add 2, or yeah, I guess 5 plus 4,058 times 26.
There you go.
Or you still get 4,058.
Change that number.
And now we have 105,513.
Okay. And so to reverse that,
Now you can divide.
right? Yeah, that makes more sense. because then you get the remainders, you get the modulus out of that. So dividing gets what?
So if you divide and round down, you'll get 4,058.
4,058. And the modulo?
Let me check. 5.
Yep, and that's the number that was encoded in there. Okay, next one.
Well, sorry, yeah, modulo 5. The next one would then be 4,058 divided by 26.
Yep.
And round down to get 156, which is what you wanted.
Okay.
And let me check, 156 times 26 is 4,056, so modulo 2.
2. Okay. So 4058 modulo 26.
You got a 4 there instead of a 5. 4058.
4058. And then now to get the
Now
last
we do
one.
156 divided by 26, and we get 6.
And modulo 26 is 6.
0. Yeah.
So
Yeah. No, modulo 0 there. So z would be 0.
modulo 0.
Modulo of 156
Right.
is 0.
Oh, 0.
Yeah, it's 156 modulo 26 is 0.
Okay. I might have done the first one wrong there.
I think that's what you want because you got all of our numbers back. You got the 6, the 2, and the 5.
I wanted the modulo as the last number to be 6.
Well, I don't think it can be.
Well, if I add 6, if I add 26 to this, it will be.
Yeah, you didn't.
Yeah, but it didn't. Well, anyway, that's the idea. So you can encode one number in another number using multiplication. So you can code information in large numbers this way. And then reverse it out as long as you go in the same order out as you went in, like a queue.
Yeah.
Yeah.
And so as long as the numbers that you're adding are lower than 26, then you're safe.
Yeah.
If you add a number that's higher than 26, then your division is going to be weird and you're going to have problems.
You know, when I first looked at this, I thought part 2 was going to be something with letters. Because 26 is also 26 letters in the alphabet.
Yeah.
So I was like, oh, there's got to be a significance to the 26. I bet at the end of it, we're going to be like having some sort of message out of this thing. You know, they just wanted us to get the lowest number. Over there. Okay.
Seems like a wasted opportunity.
Yeah, it's like a wasted opportunity to give me. It's like, oh, God,
Why 26 then?
just reverse my algorithm and, or just, you know, reverse my 9s and 1s and we're going good, but oh well.
Yeah. I like this problem. I thought it was really difficult and took a lot of time. But once you understand the patterns and understand what's happening, like Alex just described here, it was really interesting. Like really cool, and it seemed practical too.
I don't know about practical, but it's cool.
I'm gonna use it. I'm gonna use like base 52 to encode my numbers.
Yeah, okay. Well, you know, hexadecimal is already an encoded number. So
Yeah.
that's, you know, one thing you can practice with. Same with octal. Octal numbers are also encoded, base 8. This one just happens to be base 26.
Cool.
Okay.
We got one more question. One more day.
Before we go on, I do have in my repo a Python thing because somebody somewhere was able to actually reverse the math, and I was trying to reverse the math too. So if you guys ever go through my my repo and try to figure out what this is what I'm doing. I'm trying because I saw him reverse the math, and I was like, how did he reverse the math? So I'm trying to take my math and match it up with his math to see if it can reverse it. And it doesn't make any sense to me. So this part, or not that part, let's see. This part makes sense. This is the bottom half of the else, the other statement. This part, I'm struggling with the minus b, which I understand why it's there, but it's hard for me to understand how it got there. And so I've done some of the reversal up here as to like how maybe he got to where he got, and I actually ended up like eliminating some of the possibilities. There was a bunch of math in there, but really I just have to test C to see whether or not I needed to use this. This might actually interest Farouk because I saw some of this, the math I have here matches some of the math that you had on yours. And so maybe some of that translated over. But
Yeah,
yeah, if we could figure this out really fast.
There's still no way that he could have coded this without understanding the input,
Yeah.
without analyzing it like we had to do. Like, there's no way you can code it. Like, how would he know to add those 26s everywhere?
yeah, because that what you have there double. If what I understand, you have double slashes. The scroller where you at now.
Yeah.
That's dividing it by 26 and running it down, right?
Right. Yeah, just getting rid of the
So-
getting rid of the right side of the decimal.
Yeah, so you are basically calculating the next digit two, next input that you are going to get by manipulating your already existing Z.
Right. But somehow through my original algorithm, or the original, the way that I had interpreted all the algorithm, I think, I forgot if it was the top one or the bottom one. Must be the top one, because the top one has, no, that's maybe the bottom one. The top one has the B's in it. And so I can,
Yeah, where did you get? Okay.
I can kind of see where the math ended up here, but at the same time, I'm like, wow, that's a big stretch. I don't know. I don't know enough about math to figure this out.
Where are you getting the W and A in line 47?
47, W and the A. So this one, I have to go back to the if statement. So even though we have the divided by 26, so let's go back to here. And so this else statement originally started out with, what is it? It started out with, oh, let's see. Let me go back to where I had untangled the math. So originally started out with this one, right? Return Z divided by 26. And so, so the question is, what is Z? And so I can't pull it out from anywhere else. So I went back up to this if statement and pulled it out of the if statement, because on the if statement, I can solve for Z. And so on that if statement, so the divided by 26 is there, but the new Z has to equal the old Z divided by 26. And then, so what is old Z? Back up to the if statement, and I reversed the if statement and solved for the old Z. And so for the old Z, I have two conditions, either W minus A when that is greater than 0, or when W minus A is less than 26. And so I have those two conditions.
Okay, again, what is A? Like, where is it coming from?
Oh, A's and B's are essentially
Inputs.
for him. Yeah, for him it's the inputs.
Yeah, okay.
Yeah, the plus X's and plus Y.
Yeah.
This is for him, you said?
Yeah, I pulled this out of the Reddit group because I wanted to go back and see there's got to be someone who did the math instead of doing
Okay.
we did with
So for this math, reverse engineering math to work yours, you have to put your inputs there, because those A and B's are actually the digits or integers which are incrementing Z. And that's different for everyone.
Right. So you have to enter your own up here in order to make the math work.
Yes. Yeah, because he's at some point there, he's subtracting B from the already existing Z, or subtracting A from already existing Z and dividing by 26, rounding it down to get the next digit in our 14-digit integer. Because one of the instructions will basically divide the Z by 26, which will make it 26 times less, and another types can, one of them increments it 26 times.
Yeah.
Z will be equal to 26Z at the end, and another will basically divide it by 26, or just add a certain number of digits, certain number of integers to 26, but we need to divide it by 26. And to get that value, to be able to divide it by 26, it's calculating that needed integer or needed digit for that integer. for that index.
So it still has to have it still has to have pairs. I don't see how you can do it without pairs. Like pairing up two digits. What is W? That's the input, right?
Yeah, W is the input.
So Z2 must be.
C2 is he's going, I believe he's going backwards on this one.
Okay.
Yeah, he's going backwards. So he's starting with the last ones, zipping them up and going back. Well, the whole thing was called backward. So he's starting at the end and solving them using the formula one at a time from right to left with the possibilities, or basically running the backwards algorithm rather than the forwards algorithm to get the previous number. Like what we had done is we had found the pattern, but then I had to just kind of like find pairs and just kind of pop them in. So mine didn't, all the numbers didn't go in sequence, right? They all like, all my numbers filled in out of order.
You have to do it that way. Like
He found a way.
I don't know, man.
He found a way to do the math so that you can go sequentially from right to left. And that's what, that's what I'm saying. It's like, it's incredible, but I don't have the math wherewithal to have reversed that formula, that, this thing here, to reverse it. But it's possible. That's what's, kind of like cool about it and mind-boggling at the same time. Like, wow, I wish I was smart enough to figure that out. But like I said, I got halfway through it. I was able to figure out the last half by pulling out the if and finding the two conditions that are possible for it. But the first half, it was just a little bit beyond me. I can see, like looking at it, I could be like, oh yeah, that makes sense. But then what was the path that he went to from going from one to what he got? And that is still a little bit beyond me. I don't know where the different symbols got put in place. I can kind of estimate, and I think I do up here kind of estimate as to maybe how he got it, but at the same time, it's like, wow, that's a stretch. That's a stretch. I don't know how exactly he got there. So I mean, I have it up here and it seems to make sense, but at the same time, I'm looking at it, there's no way I'm going to come up with this.
So you are clear with the point. You are clear with the point.
You cannot get the last digit without knowing the plus X or plus Y values for the digit that pairs up with. You can't get it. You need to see what goes on past there in order to be able to get that digit.
I'll run this for you.
So you guys are clear. You guys are
sure
clear.
that has to be in there somewhere.
You guys, no. I think there is no pairing in here because there are two types of actually effects. Our 7 instructions or 14 instructions, right?
Yeah.
So our entire input has 14 instructions for 14 digits of our integer, right? Mm-hmm. And 7 of them have one sort of effect on our values, and 7 of them has a different types of effect on our input.
Right.
So if we, for the part 1 types of instructions, we cannot get what kind of output they will have. They will just increment our z by 26, right? But if we have our answer from that instruction, and if we find that we arrived to type 2 set of instructions, in order for our entire 14 set of instructions, 7 of them are incrementing our z, right? So they are just multiplying it by 26.
Yeah.
And 7 of them needs to divide it by 26 in order for us to get 0.
Right.
And at some point of our type 2 instructions, we are checking if there is one catch is we are checking if our input is equal to x at some point, at that point.
Mm-hmm.
So to make that type 2 instruction decrement or divide our z, we need to make our input equal to x at that point. And it's that before we run that set of instructions, we know what our x is. And using that x, we will calculate our next input for that type 2 instruction.
Right. But so because he's running from right to left, He's doing all the pops and inserts in opposite as well, right? So where we would pop going from left to right, he's pushing when he's going from right to left. When we're doing the push from right to left, he's popping from left to right. So the numbers that he's dealing with is completely different from the numbers that we're dealing with going forward. So we can't stop in the middle, let's say at the 6th digit, and compare the numbers, and the numbers will be the same because they won't be the same. He's using that formula in reverse so that he's doing his own number things with popping and pushing, the same number of pops and pushes, but the numbers he's using are based on the reverse algorithm, not on the forward algorithm that we had.
My concern that I'm not being able to figure out from line 71 to 88 is he working with a range of 7 digits or with a range of 14 digits? I can see he has a range, like for part 1, he has from 1 to 10. For part 2, he has 9, 0, -1. But length, like, is he working with 14-digit integer or 7-digit integer?
It's the full number. It's a full 14.
For example, line 80 prints 14 there.
Print line Z's. I think I put that there as a way of seeing what's happening, but the Z's are the possible Z's. It's not a single Z, it's all the possible Z's. And then he'll go through the possible Z's and see whether or not, does he go through the possible Z's? I think he goes through the possibles and see whether or not it's something that'll work going backwards. So maybe that's where you're kind of right in the sense that there's not a single path.
Mhm.
It's like when I did mine
He's
backwards,
not
when
finding
it
it as he
fanned out a
goes
little
through. He's
bit.
finding the possibilities for that digit as he goes through.
And the possibilities are limited by the formula that he has in every step. I think that's why I did the printout of the Z's. Because I wanted to see, well then, because when I did mine backwards, it grew like really fast. And there was, for me, I didn't create any kind of restriction as to what the next level will be, only that I needed to be within the ranges that were acceptable for the Z's in the next number. But what he had added in through reversing the algorithm was a smaller set of possibilities for that previous Z or previous Z to be. And so I want to know, how did he restrict that so much? And it was by reversing the algorithm. So starting to come back to me like a couple weeks ago, I guess now. 3-4 weeks ago. But anyway, I think we've dealt on this enough. We can talk about this more offline, but I just wanted to show you this, that there's also this weird, crazy way of doing it with the reversed algorithm.
Let's go to 25.
Let's go to 25.
Christmas.
All right.
Did anyone actually try to do this on Christmas Day?
I didn't look at it yet.
I think I opened it up while Javier was taking a nap, just to look at it.
I think,
I may have actually.
yeah, Alex did it on
this
Christmas.
Take long for part 1.
Oh,
I think I did.
I think Alex did it on Christmas.
okay. Yeah, I think I did it Christmas.
Let's see if I can figure
Because
it out.
I also did it on Christmas and Alex had already submitted before mine.
Well, my last time I edited this one was 3 weeks ago, so yeah, maybe
Yeah.
Christmas or the day or two after.
So this one, we have an entire like tapestry of carrots, either pointing down or to the right. And the carrots themselves are, I guess these sea cucumbers. Is that what this year? Yeah, sea cucumbers. Oh, I lost my mouse. That's there it is. And so all at once, depending on the direction, the point of the sea cucumber, the point of the carrot, everything will try to move in that direction. If there's something blocking it, then it won't move. If there's nothing blocking it, then it will move. But everything happens at once. So it's more like, oh, he moved out of the way, so I can move.
Well, they go in order, like.
Oh, did they?
One
the
group
east goes
one group goes first, and
That's
then
right.
the other group goes.
Yeah.
I think the east facing
East
ones
goes
go
first. Yeah, you're right. The east goes first.
So
and then
all
the
the east ones go if they can, and then all the south ones go if they can.
Yeah.
So they go in
And
steps.
together that makes one step, right?
Yeah, together that makes
Yeah.
one step. And so the question was, eventually there's a clearing for you to land, I guess, is the whole thing that they're going after. And so what is the first step in which no sea cucumbers move when they're all locked in and then you finally have to place it?
Los Angeles traffic.
Yeah, gridlock. So when does gridlock happen? And so based on the inputs, and I think my inputs, it's pretty large,
Yeah.
100 by 100 probably.
Yeah.
Seems to be a
That's what it looks
common
like.
thing. And so I'll share my code.
Mine's bigger than 100 by 100. Mine has 137 rows.
Oh, okay.
So maybe 137 by 137.
Oh,
I
yeah.
don't know. It's kind of random.
Let's see,
He usually does clean numbers.
Oh yeah, 138, 139,
Also different sizes even.
139 by 137.
Oh, okay.
Okay. Anyway, so looks like I created first my vector of inputs, which I just make a vector of characters. I chop this up into individual characters and put that into an array. And then I just brood it. I do the east movement. If there's a place to move, and if it's a right movement, then I go ahead and move over there. I use different states because everything is supposed to happen at the same time. But yeah, so I move to the right, and then everyone that moves down needs to move down. And I see how many moves it takes to get there to the point where the movement equals 0. And when movement is 0, I break out. And the whole time I've been counting steps. Steps plus equals 1. So it was kind of I felt it was kind of like a present to give me. It was a pretty quick thing to do.
Yeah. Quite simple. Cool.
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 All right. So who wants to go next?
Python.
Sure. Let's see yours, Farouk.
Okay, I just run my code for sample. For just testing, and here's my output. Yeah. I think this is steps they stop moving.
Yeah, looks like it. Because all the easts can't move.
So that's output. But basically, yeah, I also just brute forced it.
Yeah.
So my input, getting my input, and create my array of strings probably. I'm detecting if it has moved so that I can stop at some point, and I have my steps counter. So while it can move, they are moving. I'm moving my east cucumbers first, and still false. Currently moved. So there was a few catches or few points where I had to reconsider. Those points being so
Is he frozen?
Yeah, I think so. Yeah.
Give him a second. Hey, welcome back.
sorry guys.
No worries.
So these points being, I had to also keep track of my easts or norths when they are going over.
Right, because they have to rotate back on the other side, right?
Yeah, like I'm starting from top, right? So let's say if this part was moved down and it came here, let's say if I take this one and it comes here, right? And now I have my, let's say I have one more fish here or whatever. I have one here. And now once I move this one, and at some point I will reach to the end of my map, and here I come and check like this space is available. Right. So I move it. But according to the logic, since the previous, they have to move simultaneously, like once. My previous one was here, and it wasn't empty at that point.
Right.
So this one should not be able to move here.
Right.
So these were the points where I had to rethink. So I am like keeping track of my currently moved fish, so that if that spot has been just emptied, I should not move there.
Gotcha.
This one is for that. Yeah, I'm keeping the index, which I just currently moved for both. If my index, which I'm going to move, is not in this list, then I'm moving to that index.
Yeah. I did mine.
one.
Like I said before, I just introduced the idea of a state so that I have the previous state and the next state, and I can always use the two to do comparison. But yours works too. I mean, I think yours might even be more efficient because you don't have a complete copy of the entire grid. You only have the ones that actually moved. So it's kind of nice.
Yeah. So if it has not been set to true, it's false, which means my loop will. And because at the beginning I'm setting it to false, and only if they move, it's changed back to true. Otherwise, it's false, and my loop breaks. And I return my counter.
Okay. Cool. Cool.
It took. It wasn't instant, so it took me maybe a minute.
Oh, wow. Okay.
It's yeah.
But you got it.
Yeah.
I just brute forced it.
And me too, essentially. Let me show mine. I'm gonna show my desktop first. I'll show you my code running so you can see my map moving.
Ooh.
It's kind of too fast. You gotta watch. Are you ready?
Go.
It's gonna be like just kind of zooming.
Oh, you can add some sleeps.
And now they stopped.
Nice.
You want it one more time?
Nice.
Anyways, that's pretty much the final map where they all the east ones over here blocking in a lone group of south guys.
Yep.
And same down here, a bunch of southeast blocking in the easters. Yeah, that's that. Let me change what I'm sharing now. I'll share my code. All right, so here's my code. I formatted my input like this. So I have an array of strings for every row. So this is for the sample input. Now I have a few global variables here, my C and my D for my input length. So the total length, the number of rows, and my D is the number of columns. Now I created a new input. So my regular graph is my input, and I need a new input. It's going to be a copy of that soon. And then I created separate functions for moving east and moving south. And they're pretty much the same, so I'll just explain one. It's going to take in a J, so I think that's the column that I'm dealing with. And a K. What is K? I don't even know. Let me see. Okay, so since J is going to be the row and K is going to be the column, because I used I for my number of steps that I'm running. So yeah, I have my row and my column. So pretty much the index, the location of that little, what are these guys? Sea cucumbers, right? So now I'm just checking.
Yeah.
If we're at the end, I guess, then we're going to go back to the beginning. If he can, I think. Yeah, so I'm checking if the space is empty. If it is, then I'm going to go back to the beginning, the very first column in that row. I'm going to put the sea cucumber there, and I'm going to set his initial location back to empty. So a dot. Or else, if he's not at the end of the row, then I'm going to check, is the next column empty? If it is, then I'm going to move him there and move his initial location to a dot. And I also have a counter that I'm counting called moved. So I'm going to use this. It could have been just a Boolean, I think, but I wanted to see how many moved on each step. So that's essentially what I have for move east and move south. I'm just using the different little dudes, the right arrows and the down arrows. Now for my main loop, I'm keeping track of two things here, my step. So I need to know what step am I on, and I'm keeping track of how many moved. So I'm gonna loop my favorite number, 9999999. So I'm gonna loop this many times. I just chose an arbitrarily large number just to make sure that I looped enough steps where it would actually complete. And yeah, I can get rid of that console log. That was just my map so that I could visualize it. Now I'm gonna make a copy of my input. So I'm just using JSON parse, JSON stringify to get a copy of my input array. And I'm gonna set my moves to 0 for each loop, because for each loop, each step, I wanna see if anybody moves. Now I'm gonna loop through my rows and my columns, and I'm gonna move all of my eastern dudes. So I'm gonna check if an element in my grid is a guy that faces east, I'm gonna see if he can move. If so, he's gonna move. Then I'm going to make another copy of my array. So now my new input is now the current one that has all of the migrated sea cucumbers. So now I'm gonna reset my input to be my new input now. So it's gonna be the same as my new input. So that's essentially my way of dealing with the different states to keep everything going simultaneously. I just create a copy, I move everything in that copy, and then I switch the copy with the original and move everything again. And so, yeah, I do the same thing with all of my south-facing dudes, my southeast. And then I'm going to increase my step because I've now finished one step. And I check if anybody moved. If nobody moved, so if moved is going to be 0 still, that means I'm finished and I can console log what step I'm on. Oh, why do I have a step when I can just use I? That was stupid. Yeah, this is very redundant. That's all we need there. I pretty much was my step. Yeah, and if nobody has moved, then I'm setting my input to my, or sorry, if people have moved, then I need to run again. So I'm resetting my input to be equal with my new input. Why am I doing that? Input.
Yeah, because every time you go back on top, so that's why you need to redo it, but with the new one.
New map, yeah.
Yeah, with the new map. Otherwise, you will keep doing the same stuff over and over if you don't move. So that's why you need that one.
I think maybe you just pasted it in there as part of your last one. But yeah, you only need, I think you only need one of those, the first one or the last one.
Yeah, I don't think I need this last one. I don't know. I'm afraid to touch it because it works right now.
Yeah. As long as you alternate back and forth,
Yeah,
should be good.
I think I do. I think I only need one. I'm confused why I have two.
The last one probably needs to go. The new input and the input needs to alternate, but that last one. Is,
No, maybe your second one, yeah, maybe that one.
you never change the.
Yeah, new input never changes.
Yeah.
It's only input that's being passed in.
And the next one reuses new input to get the south moving.
Or well, no, I am moving. I'm changing new input. New input's the one I'm changing. Okay. Yeah. So I guess because new input is a global, I do need to have it again.
Right. You're changing new input, but your for loop is checking on the old input, right? Because you have the if statement, if input equals whatever, but it needs to check the old input.
Yeah.
So after you move.
So I was confused because
So
in my.
Yeah, so 74, you've moved all the easts, right? Because you take all the easts and you put that into the current state.
Yeah.
And then you move all the souths. But all the souths should also check with input like you do in 77, because that was the previous one.
Yeah, I think it's fine how it is. I think I do need that line 86 also and 74 because I need to reset my initial state both times.
But if you
Because I have input and new input as globals, they're global
right,
arrays.
but in, you know, in 86,
Yeah,
so new input is now the same as input. The for loop is finished.
it's
Go
not
back
the-
up to 65. For loop's not finished in 86.
well, right here, input gets set equal to new input,
Right,
but
so
then
all
new
the
input
easts-
changes. New input changes here.
Right, so all the easts have been moved.
Yeah,
So now you make the easts part of history, right? So now input the history now contains all the east movements. Then you run that one. So 77 is now running against input, which is basically the history, but it's modifying your new input, which is your future state. Right?
yeah, but then now before I run my next loop, I need to get my initial state to have the
Well, that's-
new state.
And 86 does that,
Yeah, so that's what I'm saying. I think I need both of these.
but then you don't need 65.
Yeah, my new input doesn't need to be reset here. Yeah, because
Because you already have new
that
input.
one,
And
that
it says
one, that one can be
input-
reset, yeah,
At 86, input and new input are the same.
yeah. So input's the one that I need to reset. New, oh, I do need this for the initial time though,
Then move it out of the for loop.
yeah.
Option. You can command
I used to use
option.
keyboard. I'm so used to using my other keyboard. Just option, okay, thank you, yeah. Okay, it's cleaned up a little. Yeah, I know I didn't spend too long on this one.
Yeah, I think I knew because I had done the ones in the past. Day 25 is usually kind of a medium, like a day between, I would say, 10 and 15 kind of.
It's always like that?
It's always been like that from the ones that I have finished in the past.
Just a victory lap.
It's kind of a kind of a give me, kind of like, oh, it's Christmas. I'm not gonna like take you away from your family for 5 hours. Here's an easy one to make
I
you
was
feel good,
thankful for that.
but go enjoy Christmas with your family kind of deal.
I really liked the ones that took about like an hour and a half because I could finish during Harvey's nap time.
Yeah. And then part two was always a give me as long as you finished the rest of the other ones.
Yeah,
And so when you were asking me before, oh my God, part two must be really hard. I was like, yeah, maybe.
yeah.
Because I didn't want to spoil it for you guys saying that, yeah, no, it's
Does anyone want to see part two? Can we share?
sure.
So here was part one. And yep, you got down to here, right? You need 50 stars, you get 1 star. You only had 49 stars to go. So after you get all 49 stars up until this point, you get 1 extra. You now have 50, and it says you can remotely start the sleigh. And it lets me remotely start it again, which is kind of cool. So then you get this cool victory screen with the snowflakes. You use all 50 stars to boost the signal and remotely start the sleigh. So you pretty much saved Christmas now,
All
right? And now I like this. This is cool. The crab submarines come with colored lights.
Ooh.
And you can see that on the calendar too. So when you look at the calendar, you see all the like lights moving back and forth.
Oh,
They're only going horizontally because they're crab submarines. I like that. So they're leading you back because you're in the bottom of the Mariana Trench.
Yeah. It's also nice to kind of fade out as you go to the bottom as it's deeper.
Yeah,
and
it's darker, then bright at the top.
Yeah.
Yeah, and then it also tells you that there's Easter eggs in some of the questions. Actually, every question has at least 1 Easter egg, and they highlighted them for you, which you would never have found before. So you see here, like this one has a yellow underline under it that it didn't before. So if I hover over that, it's got some
I heard you like language.
funny text. I heard you like lanternfish. That's one of them. And there was one question with an octopus, I think. And he called them the Dumbo octopuses.
Dumbo octopus, Farouk's favorite.
Yeah, what was that?
Oh,
Yeah, and so this one here was funny. I know it's weird. I grew up saying octopi too. Apparently octopuses is correct, or octopi is also correct, I think.
Maybe they're both valid.
Yeah, so I thought the Easter eggs that were in there that we never knew about, or that Alex never told us about, was kind of fun.
Actually, never.
until this, yeah.
In the many years I've done this, I actually never went back to go to the Easter eggs.
Okay.
Up until this 11, I was brute forcing some graph related problems, but at 11, like I spent a lot of time brute forcing it, trying to brute force, but no, then I had to find appropriate or proper breadth first method and use it on that.
Farouk, if you finish soon, you can still be in the top 10K.
Oh, really?
Come on, man.
Less than 10,000 people have
You
finished
got
all
30,
45
you're gonna
days.
beat 31 people to the top.
Okay. I'll try. I have 2 days left, maybe this weekend. 2 and
The
12.
number is increasing really slowly
Yeah.
now, so you could
Yeah,
probably do
I
it.
wouldn't worry about it too much.
Yeah.
31 people.
You would never know anyway.
It's actually their points. I don't think they're actually people. I don't know. I think each, as it says right there, each star represents 5,447 users.
Yeah.
So you have
Oh,
31 times.
No, that's for each star. The numbers are the number.
Oh,
of
so the
users.
numbers correct?
Yeah,
Okay.
So the stars here, there's only 3 stars because.
Yeah, that makes sense. Okay.
But yeah, the number of users here is 9,000.
So you got 31. 31 people. You got to be one of the next 31 people.
Yeah. You got to beat these.
Other.
5,144 people have finished day 25, but
So
not
there's
finished
like
all the other ones.
4,800 who have not finished it yet, right?
Yeah.
Or is
Right.
that the other way around? Is the silver the number that haven't finished it, or the one that
I think this is the number that have finished part 1, but not
part 1.
but not part 2?
Yeah, which is crazy for day 19 for me. Like almost everyone who finished part 1 for day 19 finished part 2 also.
Yeah, but not many people did part 1.
That's true.
The numbers dipped significantly.
Yeah,
in
that
19.
was the big day. It dropped a lot on 18 too. 18 and then 19
Yeah.
had big drops. It almost half the number of people from 17. That's interesting.
Interesting. It looks like half side of the
Yeah, it
Christmas
looks like
tree, you know,
There
the
was a big
stars.
drop from 7 to 8. Lost like almost 20,000 people, and then it was steady for a little while.
Yeah, you can see all the grays on day 8 too. Not many people finished the second part.
Yeah.
Same with day 21, day 14.
Yeah, 21 and 22 have a lot of grays.
Yeah.
Understandable.
Yeah.
Well, cool.
All right.
Good job, W coding.
Well, I hope you enjoyed this year. Not sure when you guys are going to be watching this, but it's not going to be Christmas.
Maybe it'll be Christmas
Enjoyable run.
tree when my day 24 code finally finishes running.
All right.
We
Let us know how that goes.
just brute force it with all the options.
You know what we need? We need a bigger computer. That's what we need. Bigger hammer to the solution.
It was
Anyway.
my first time trying Advent of Code. Thanks for the opportunity, guys. I enjoyed it.
You seem
Honestly.
to enjoy it a lot. I'm happy.
Yeah, I think it combines the fun with the coding because sometimes when we ask algorithmic questions, you don't see the fun part. It's just calculations and some logic. But this joint like bring the adventure of fun to the algorithmic problems.
That's
Yeah, I
how I
like
feel about it too. I agree.
I think it was also, nice to do it together because we can see the different approaches or the same approaches, depending on how we wanted to do it, but and also see in different languages.
True.
You can kind of push each other on.
Yeah, it was definitely motivating to have other people doing it too.
Pretty good. So I encourage you guys who haven't finished to keep going, get it done.
Yep.
There's no hurry, but there's another one coming next year, so you have 11 months to finish. I will tell you that once the next one starts, you really don't want to go back and do the previous years. But it's I do encourage you guys to do the previous years too, when you have the time in the middle of the year, whatever. Like I said, I'm trying to go back and finish some of the years, past years I have, but it's also kind of slow going. But I think I finished 2015, so maybe.
Was that easy? I wonder if that was easier than some of the later years, because it was the first time. Because I assume he's adjusted the difficulty level and kind of gotten into a flow now.
Yeah, I mean, like I said,
out a little bit easier or even harder.
the past years I've skipped fewer, or skipped part B of fewer. Like this year, I feel like I skipped more part Bs and just said, okay, I'm gonna just do this later. Whereas previous years, I actually suffered through the part B. Now, I don't know if that's because I have less time now. I don't know if that's like me and my lifestyle has changed. Whereas when I was younger, I was like, all right, let's do this. Now I'm just like, oh, I got other stuff I gotta get done. or if it was adjusted. But maybe it's both. You know, I'm sure, you know, when and as it's gotten more popular and people have been more and more people have been coming on, I'm sure that, you know, there have been people who have finished it asking for harder and more challenging questions. Whether or not he's actually appealed to them, it's hard for me to say, but maybe, yeah. I would say yes. It probably has gone at least a little bit harder.
Makes sense.
Anyway, thanks.
It's been fun.
Hope it's been fun for you guys as well. And maybe we'll see you next year.
Yeah. All right. Bye-bye.
Right.